we're going to cover surface area of pyramids and cones today. So first, all the pyramids we're going to be dealing with are regular pyramids, which means the base is a regular polygon and all the lateral faces of the pyramid are congruent isosceles triangles. Just kind of sets us up to know that we're going to be able to use these formulas that I'm going to give you. So the other important thing is going to be slant height. Now we're going to use L, and it's going to be kind of a cursive little L that we're going to use for slant height. The slant height is the height of any of the triangular lateral faces. So if we look at the net of a pyramid, this height right here, the height of this, that's going to be your L. So sometimes we aren't going to be given that dimension, so we're going to have to find it. And we're going to have to find it using the Pythagorean theorem, which we did the last chapter. So that's the first thing we're going to do, is we're going to find the slant height of some pyramids, and we're going to round to the nearest inch. So I've got my pyramid. Not going to be the best drawings, I apologize. Okay, now I know that the height of the pyramid is 10 inches. And then I'm going to tell you that each side is 16 inches, so it has a square base. So what I need to do is I want to find the slant height, which is going to be this side here. So I know what this length is. I could find this length, right? Because if it's a square, well, all the way across to 16. So that means halfway across is going to be 8 inches. So basically, I have a right triangle with one leg of 10 and another leg is 8. So to use the Pythagorean theorem, we could take 10 squared plus 8 squared to find my c squared. So I can go on to say that 100 plus 64 equals c squared. So 164 equals c squared. To solve for c, remember we want to find the square root of both sides. So to the nearest inch, c is about 13 inches. All right, this time we've got this pyramid. This time I have bases of 25 meters. So once again, we have a square, and again, I'm given the height of the pyramid, and this time the height is 30 meters. Okay, so once again, I'm looking for that slant height here. If I know all the way across the square is 25, then I know that halfway across would be 12.5. So once again, I've got a right triangle with one side measuring 30, another side measuring 12.5. So to find my missing side here, or my slant height, we're going to take 30 squared plus 12.5 squared equals c squared. And so when you plug those in the calculator, find the square root, you end up with c is about 33 meters. Okay, so now let's move on to the actual formula. So to find the surface area of a regular pyramid, what we're going to do is we're going to take the area of the base, which once again we're going to let be big B, and then we're going to take 1/2 times the perimeter of the base, and then L, which L is going to be my slant height. So we're just going to go ahead and apply that formula here. So I've got my pyramid, and it tells me that it has a square base with sides that measure 10 centimeters, and it's going to actually give me my slant height and tell me that my slant height is 13 centimeters. Okay, so we need to find three pieces of information here. We need to find first my base, so the area of my base. Well, my base is a 10 by 10 square, so 10 times 10 gives me 100 centimeters squared for my base. To find the perimeter of my base, I'm going to add up all the sides. The square with 4 sides, measuring 10 centimeters, gives me a perimeter of 40 centimeters. My L is my slant height, which they give me to be 13 centimeters. So we're going to plug those into my formula. So I'm going to take the area of my base plus half my perimeter times my slant height. And you get a surface area of 360 centimeters squared. All right, these ones, the formulas look a little tricky, but as long as they give you the right pieces of information, they're usually not too bad. This time, my base is a square with sides measuring 25 centimeters, and my slant height is 42 centimeters. Okay, so once again, we first want to find the area of my base. So my base is a 25 by 25 square, so we're going to take 25 times 25, and we get 625. The perimeter of my base, if we take 25 plus 25 plus 25 plus 25, we get 100. And my slant height, which they give me, is 42. So if we plug all those into our formula, we have the area of my base plus half my perimeter times my slant height. And whenever you punch all those into your calculator, you should get 2,725 centimeters squared. Okay, now similar to the surface area of a pyramid, surface area of a cone, we're just going to be plugging some numbers into a formula. It's actually the same formula except the area of a base. If I have a cone, the area of my base is always going to be the same as the area of a circle, so we can be a little more specific. So let's jump into an example here. Let's say I have a cone that has a radius of 2 centimeters and a slant height of 8 centimeters. This one, just like whenever we're finding the surface area of a cylinder, we can just plug them right into the formula. So surface area equals pi times r squared, which all of this they give you, plus pi times r times L. So they give you all those numbers, you've just got to plug them in the right spot into the formula. Let's round to the nearest whole number. You should get 63 centimeters squared. All right, let's have one that looks about like this. And this dimension here is 16 centimeters. I have a slant height of 15 centimeters, so hopefully first thing you notice, I'm given my diameter, I need my radius, so if all the way across is 16 centimeters, I know that halfway across is going to be 8 centimeters. Once I have my radius, I can go ahead and plug them right into my formula. So we're going to take pi times r squared plus pi times r times L. And whenever you punch those into your calculator and round to the nearest whole number, you should get 578 centimeters squared.